Most people still believe that building a house means thick brick walls, months of disruption, and energy bills that never seem to go down. But what if I told you that one construction system is quietly outperforming traditional methods on speed, energy efficiency, and compliance with modern building regulations? Today, we're talking about SIP panels, structural insulated panels, and why they are becoming a key technology behind modern modular housing. If you are interested in building faster, smarter, and more energy-efficient homes, this video will give you a clear, practical understanding of how SIP technology works, where it excels, and where it may not be the right choice. By the end of this video, you'll understand why SIP panels are increasingly used in modular housing, how they compare to timber frame and brick construction, and how long they can realistically last when built correctly. Before we go further, if you are interested in modern construction methods, modular housing, or future-proof building systems, consider subscribing to the channel. New videos are uploaded regularly, breaking down construction technologies in a clear and practical way. Now let's start with the basics. Structural insulated panels, or SIPs, are factory-manufactured building panels that combine structure and insulation into a single engineered component. Each panel typically consists of a rigid insulation core, usually polyurethane or PUR, bonded between two structural boards, most commonly OSB. Unlike traditional timber frame construction, SIP panels contain no internal stud-work. The panel itself is the structural element. This single difference removes a huge number of weaknesses found in conventional construction. In my opinion, this integration of structure and insulation is the biggest advantage SIPs offer, because fewer layers mean fewer mistakes, fewer thermal gaps, and far more predictable performance. As building regulations have become more demanding under Part L, SAP 10, and the upcoming Future Home Standard, construction methods that rely on assumptions and default values are increasingly risky. SIPs remove many of those uncertainties. Because SIP panels are precision engineered, their U-values, thermal bridging performance, and airtightness can all be calculated at the design stage. This allows energy performance to be modeled accurately before construction even begins. If you've ever seen a project delayed or made more expensive because it failed an air test or SAP assessment, you'll understand why this matters. Quick pause here. If this information is already useful, let me know by liking the video. It helps the channel reach others who are researching smarter ways to build. One of the strongest advantages of SIP panels is thermal performance. SIP walls and roofs can achieve very low U values without excessive wall thickness. In many cases, SIP walls outperform timber frame systems while remaining thinner, which directly increases internal usable space. This is particularly important in modular housing, where every square meter matters. However, insulation alone does not guarantee energy efficiency. A building with excellent insulation but poor airtightness will still perform badly. This is where SIPs excel again. SIP structures are inherently airtight due to their manufacturing accuracy and reduced number of joints. When installed correctly, many SIP buildings exceed airtightness requirements without complex additional measures. With current regulations now requiring air testing on every dwelling in multi-unit developments, SIPs offer consistency and reduce the risk of failure across identical units. Thermal bridging is another area where SIP panels outperform traditional methods. Timber frame construction contains repeating studs that interrupt insulation and create thermal bridges. SIP panels, by contrast, provide continuous insulation with far fewer weak points. Pre-calculated thermal bridging values can be supplied early to SAP assessors, improving compliance and reducing the need to compensate later with additional technologies. From a structural perspective, SIP panels are also extremely stable. They experience minimal shrinkage and settlement compared to timber frame construction. Over multi-story buildings, this difference becomes significant and helps maintain airtightness, finishes, and long-term performance. A common question is lifespan. When properly designed, protected from moisture, and installed correctly, SIP structures are expected to last as long as traditional construction. There is no evidence that SIP buildings deteriorate faster than timber or brick when built to correct standards. In my opinion, SIP panels are not a niche or experimental system. They are a mature, proven technology that aligns extremely well with modular housing and modern regulatory demands. That said, SIPs are not always the cheapest upfront option. For very small projects or highly budget-constrained builds, traditional methods may still be more suitable. SIPs require early design commitment and precision planning. However, when speed, energy performance, predictability, and long-term value are considered together, SIP panels often become the smarter overall choice. As we move toward tighter regulations and higher energy standards, systems that remove uncertainty will continue to gain ground. If you are exploring modular housing, affordable housing, or future-proof residential construction, SIP panels are a technology worth understanding properly. If you'd like more videos breaking down modern building systems, modular construction methods, and cost-effective housing solutions, subscribe to the channel and turn on notifications so you don't miss the next upload. Thank you for watching, and I'll see you in the next video.